Hey guys, today I'll be going over adding and subtracting rational expressions. We'll be doing about 5 or 6 problems, so this might be a long video. I would recommend you go through the problems as I'm going through them. You write them down in your notebook. Feel free to pause the video and rewind if I'm moving a little bit too fast. Okay, so let's get started. So just some quick tips for adding and subtracting rational expressions. So to add or subtract rational expressions, you have to first find a common denominator, preferably the least common denominator, because that's the least amount of work. Remember, you cannot add or subtract fractions unless they have an LCD. And then lastly, don't forget to state the restrictions, meaning what your variable cannot be. So remember, that just means any values that would make your denominator equal to 0. So you've done this before, but you've done it with regular fractions. So let me explain what I mean. So remember, when you add or subtract fractions, you can't just add the numerators and add the denominators, or subtract the numerators and subtract the denominators. So for example, let's say you have two fractions like 2/3 plus 4/9, right? So you can't do this. You can't do 4 plus 2 is 6, 9 plus 3 is 12. You can't do that, right? This is wrong. What you first have to do is find your LCD and then convert all your fractions so they have this LCD. So in this case, the least common denominator for 3 and 9 would just be 9, right? Because 3 goes into 9. And 9 goes into 9, and that's the least common. So that's the smallest one. You could use a bigger common denominator, but again, you would have to simplify more if you used a bigger common denominator. And so the second step would be to convert any fraction so that they both have a denominator of 9. This is fine because it's already 4/9, but we need to convert this fraction. So what we would do is 2/3 times, well, if I want my denominator to be 9, I have to multiply by 3. But if I multiply the denominator by 3, I have to multiply the numerator by 3. So this whole fraction then becomes 2 times 3 is 6/9. And then I would add the 4/9, and that would give me 10/9. Okay? And this would actually be your answer for adding these two fractions. All right, so just remember that we're going to be basically doing this process, but it's going to look a little bit more complicated because we're going to be using rational expressions instead of just regular fractions. But it's basically the same concept. The concept is to get the same denominator so that you can combine the fractions. And this applies for subtraction as well as addition. Okay, so let's get started with our first example. These examples are straight from the book. I'll leave the pages in the caption, in the comments, so that you know where to look in your textbook in case you would like to review these problems. Okay, so let's get started. So the first thing you want to do is notice this is a plus, so we can't just combine these right off the bat. We don't have the same denominator, so that's a problem. So the first thing we're going to do is factor. Okay, so you want to factor first because factoring is going to help us figure out our LCD. Okay, so the first fraction, I can't really factor anything out, so I'm going to leave it the same. For my second fraction, I can't factor the top because they don't have a GCF, greatest common factor. 2x and -1, they have nothing in common, so we're going to keep it the same. But the denominator is a quadratic that can be factored. Remember, you're looking for two numbers that multiply to 2 and add to -3. So let's see. That'll be -2 and -1. Okay? Now that you've fully factored, now you want to come up with your LCD. Okay? So let's take a look. This fraction has an x minus 1. this fraction has an x minus 1. So the x minus 1 is going to get listed just once because they have it in common. Okay, then look for what they don't have in common. So the x minus 2 they don't have in common, so we need that as well. So your LCD is x minus 1 times x minus 2. Okay. So now, if you look at the second fraction has your LCD, x minus 2, x minus 1. So we don't need to touch this second fraction. The problem is this first fraction that only has an x minus 1. So what is this denominator missing? Well, clearly it's missing the x minus 2. So I have to get this denominator to look like this denominator, x minus 1 times x minus 2. So I'm going to take my fraction, and in order to have the denominator I need to multiply by my x minus 2, which is the piece that's missing. Now, if you multiply the bottom by x minus 2, you got to multiply the top by x minus 2 to keep things balanced. Also, remember that x minus 2 over x minus 2, this value is technically 1. So you're taking your fraction and technically multiplying by 1, which means you're not changing the value of this fraction. So that's why this process is okay. All right, so at the bottom, I'm going to have x minus 1 times x minus 2, okay, which is exactly what I need. And at the top, I have x times x minus 2. Now, this is a quantity, so this x needs to get distributed. Okay, so this is going to be x times x, so x squared, and x times negative 2, so minus 2x. Okay, now this right here is now this fraction. So I converted the first fraction to this. So I'm just going to rewrite my whole sum. So let's see. So I'm going to do this. I'm just going to delete this. And this is now my first fraction, right? And then I'm going to add, let's see, plus, I'm going to add this fraction, which was my original problem. X minus 1, x minus 2. Okay, nice. So now, if you notice, these two fractions have the same denominator, so I can go ahead and add my top and keep my denominator the same. Remember, when you're adding fractions, you keep your denominator. I reversed them, but that's okay. It doesn't matter the order. Okay, at the top, I'm going to have x squared minus 2x, and you could just multiply across. Sorry, not multiply, add across. So x squared minus 2x plus 2x minus 1. Okay, so x minus 2 is on the bottom, x minus 1 is on the bottom. Okay, at the top, you can tell that negative 2x and 2x will cancel, so you're going to be left with x squared minus 1. Okay, we're almost done. But you'll notice the top here can be factored. So let's just factor it because we want to see if we can cross anything out. So this top quadratic is the difference of two squares. So it's going to be x minus 1 times x plus 1 divided by my denominator, x minus 2 and x minus 1. Okay, as you can see, I can cross x minus 1 out with x minus 1. I'm left with x plus 1 over x minus 2. This is my answer, right? Oh, never mind. Not going to circle it. Okay, so this is my answer. Now, you still have to state your restrictions because we are working with fractions. So let's see. I'm going to just look at every point just to make sure I catch all my restrictions. So this is 1 and 2. So x can't be 1. X can't be 2. And it looks like it's just 1 and 2, right? So this is my full answer then, including the restrictions. Okay? All right, not bad. Let's go on to the next problem. Example 2. X plus 2 over x minus 1 plus negative 2 over x squared minus x. Okay, first step, factor, right? So I can't do anything to my first fraction. I'm just going to rewrite it. Sorry, let me just... Okay, so I'm just going to rewrite it. X plus 1 over x minus 1 plus negative 2. Okay, so I can't factor anything from that first fraction, but here I can take out an x. Greatest common factor is x, so this is x minus 1. Okay, perfect. Let's come up with our LCD. Okay, so look at both of your denominators. They both have an x minus 1, so let's write that once because they have it in common. And then this fraction has an x that this fraction doesn't, so we need an x as well. So our LCD is x times x minus 1. Again, the second fraction already has the LCD, so we don't have to touch this fraction. The only fraction we need to manipulate is that first one. So let me rewrite that first fraction. X plus 1 over x minus 1. And we need it to have our LCD. So it's missing an x. This denominator is missing an x. So I'm going to multiply the top and bottom by x over x. And I'm just going to rewrite the rest of my problem. So negative 2 over x times x minus 1. All right. So looking at this one, I'm going to combine them. I'm going to have, so x minus 1 times x, I'm going to get x times x minus 1. So at the top, remember, this is a quantity, so x times x plus 1, you got to distribute that. So it would be x times x, so that's x squared. X times 1 is plus x. Okay, and I'm just going to rewrite my second fraction. Okay, notice now our two fractions have the same denominator, which is the goal. Okay, so I'm going to combine them all under one fraction that has our denominator. And then I'm going to add the top, x squared plus x minus 2. Very good. All right, you're almost done, but you should try to factor the top to see if anything cancels. Let's see if it's factorable. It looks like it is. So let's see. X and x, two numbers that multiply to negative 2 and add to 1. So plus 2 minus 1. That should do it. Okay, very good. Let's cancel out any factors we have in common. So then the final answer is x plus 2 over x. Perfect. And then our restrictions. So looking at the top, from our original, x can't be 1 because of x minus 1, and here because of x minus 1. But also x can't be 0 because here x is by itself. So if x was 0 here, this whole denominator would be 0. So x can't be 0 and x can't be 1. And that's our final answer for example number 2. All right, moving on to number 3. Example 3. Okay. All right, again, first step is to factor, so I'm going to do that over here. X over, factor this, difference of two squares. So x minus 2, x plus 2, okay, plus 1 over x plus 2. Let's write our LCD. So our LCD, let's see, they have an x plus 2 in common, so let's list that. And then this fraction right here is missing an x minus 1. Sorry, an x minus 2. So that will be our LCD. Okay, again, one of our fractions is fine. So we're getting lucky here because we don't have to change both fractions. The only fraction that's not okay is the second one because it's missing an x minus 2. So rewriting everything, I like to let me rewrite that first fraction. So it was x over x plus 2, x minus 2. right, plus 1 over x plus 2. But we said this is missing something. So let's multiply by what it's missing. It's missing an x minus 2. Okay, so moving on, rewriting everything again. So these are time consuming. I do recommend you write out each step just so you don't mess up because there's a lot of algebra going on. Okay, so the bottom of the second fraction is x plus 2, x minus 2, which is what we needed, right? The top is 1 times x minus 2, so that's nice and easy. It's just x minus 2. Okay, so let's combine them under one fraction. So x plus 2, x minus 2, and the top is going to be x plus x minus 2. Okay, well, what's that? X plus x is 2x minus 2. The bottom is x plus 2, x minus 2. All right, almost done. Let's factor out the top just to make sure that we simplify as much as possible. So the top will be, I can take out a 2, so then I'll be left with x minus 1. So unfortunately, that doesn't really help us out because nothing is going to cancel. So this is actually our final answer right here. Let's do our restrictions. So from here, 2 and negative 2. 2 and negative 2. So 2 and negative 2, and it looks like that's it, right? So this is our final answer, including the restrictions. Guys, please don't forget to write your restrictions, okay? Very important. Okay, moving on. All right, so this is subtraction. So with subtraction, it's the same thing, except there's one little part, which is when you are subtracting, this minus needs to be distributed to every term. Okay, so it's basically the same exact process, except one extra step, and I can't forget, which is to distribute that minus. Okay, so let's try this out. So I'm gonna factor first. So x squared minus 2x, I can take out the greatest common factor, which is x. So x minus 2. All right, x plus 2 on top over. Here I can take out the GCF of 2, so x minus 2. Okay, let's write our LCD here on the side. Okay, so check what they have in common. They have an x minus 2 in common. Write that one time. Then what's left over is a 2 and an x. So I like to put those in the front. It just looks cleaner. Okay, so your LCD is right here. Okay, so now this is interesting because we need to actually change, both fractions need to be changed because this one doesn't have the LCD 2x times x minus 2, and neither does this one. So it's extra work here. Okay, so let's begin with our first one. So x plus 2 over x times x minus 2. Okay, I'm just going to leave some space and just write my minus over here. X plus 2 over 2 times x minus 2. Okay, and the reason I left some space is because this fraction needs to be manipulated. We need to multiply by what the denominator is missing. So here we have an x minus 2. So we're missing the 2. So I'm going to multiply by 2 over 2. Now with this fraction, we have a 2, we have an x minus 2, so it's missing the x. So I'm going to multiply this fraction by x over x. All right? Okay, so now up top here, I have 2 times this quantity. So again, remember we're going to distribute the 2. So 2 times x plus 2 times 2, which is 4, all over our LCD 2x times x minus 2, right? Because this 2 times x minus 2 gives us 2x times x minus 2. Minus, okay, same thing over here, that x needs to be distributed. So x squared plus 2x up top, and the denominator is the same one as this. 2x times x minus 2. Perfect. Now they both have the same LCD. Okay, so now what I'm going to do is combine them under the same LCD, which is 2x times x minus 2. Now, we're going to need to be careful. I'm going to list my first terms, 2x plus 4. Okay, so now you see this minus? It's saying minus this whole quantity. So this minus needs to get distributed to each term. And that's where a lot of you guys will forget. Okay, so be careful. This minus has to be distributed. So it's going to be minus x squared, and then negative times 2x would be minus 2x. Okay, so that's the only difference between addition and subtraction, is this little part where I'm distributing my minus. Okay, let's see. Okay, so actually 2x minus 2x are going to cancel. So up top, I'm just going to have, and I'm going to put it in order, negative x squared plus 4. And then on the bottom, I have 2x times x minus 2. Okay, now this negative, I'm going to try to factor that out because I have a feeling, because if I factor out that negative, I'm going to have the difference of 2 squares. So let's do that. I'm going to factor out a negative 1, and I'll end up with x squared minus 4. So that's why I did that, because I'm going to end up with the difference of 2 squares. And then 2x times x minus 2. Okay, so I'm going to factor out the difference of 2 squares here. So x plus 2, x minus 2. See why I did that? Because now things are going to cancel. So 2x times x minus 2. Okay, so these are going to cancel. I'll be left with negative 1 times x plus 2 over 2x. You can distribute this negative 1 if you want, but it's not that important to do that. You can, again, do it. Either way is fine. All right, restrictions now. So if you look over here, your x can't be 0. And if you look at the x minus 2, your x can't be 2. And that is our final answer. All right, just 2 more problems to go, and let's keep going. Okay, example 5. Again, this is subtraction, so no big deal. I just showed you how to do that. Okay, so let's factor. Minus, okay, 6x minus 7, I can't factor anything out. There's no GCF, so we're just going to write it the way it is. Okay, this is a quadratic, so x and x. 2 numbers that multiply to 2 and add to negative 3. So negative 2 and negative 1. Very good. Okay, LCD. Put it over here. LCD. Okay, so they have an x minus 2 in common. So that is going to be part of our LCD. And then there's an x minus 1 left over. All right. So one of our fractions is good. This one has our LCD. We just need to change that first one. So let's do that. X plus 3 over x minus 2. Well, that one needs to be multiplied. The LCD is missing an x minus 1. So we're going to multiply by x minus 1 over x minus 1. And then just to rewrite the rest of my problem, minus 6x minus 7 over x minus 2, x minus 1. Okay. Okay, so that first fraction, let's combine. X minus 2 times x minus 1 is x minus 2 times x minus 1. Up top is going to take us a little bit more work. We have to FOIL this. Okay, so first, x times x is x squared. Outer x times negative 1 is negative x. Inner 3 times x is 3x. And last, 3 times negative 1 is negative 3. We'll take care of that in a little bit. Let me rewrite the second part. All right, so let's see. This quadratic, let's combine like terms. So I'm going to have x squared, combine negative x plus 3x. That's 2x minus 3 over x minus 2, x minus 1, minus 6x minus 7 over x minus 2, x minus 1. Well, let's combine the fractions under one fraction. So x minus, x minus 2, x minus 1. Okay, the top. So we have x squared plus 2x minus 3. Okay, again, you see this minus right here? It's saying minus this whole thing. So this minus has to get distributed. So minus 6x, and then negative 1 times negative 7 is positive 7. All right, now let's combine like terms. So x squared is just x squared. You know what, I'll do it here. Sorry guys, I keep clicking something by accident. X squared, okay. 2x minus 6x, so that's going to give us negative 4x, right? And then negative 3 plus 7 is going to give us plus 4. All under x minus 2 and x minus 1. Okay? Let's see if we can factor the top. Maybe things will cancel. So two numbers that multiply to 2 and add to two numbers that multiply to 4 and add to negative 4. So what's that? X and x, and then we have negative 2 and negative 2, which is going to help us out because we're gonna have x minus 2 that cancels. So x minus 2 will cancel with x minus 2. Then we're going to have x minus 2 over x minus 1. This is our final answer. Our restrictions are the following. X can't be 2 and x can't be 1. And we're done. All right, very good. Last problem, guys. We're almost there. Example 6. Okay. Again, we're going to factor first. This is x minus 1 over x plus 5. Okay, minus x plus 3 over two numbers that multiply to 5 and add to 6. Easy, 5 and 1. Plus 5 plus 1. Okay, LCD. X plus 5 is what they have in common. Okay, what's left over is my x plus 1. This is my LCD. One of my fractions is good, so we just have to modify our first fraction. So x minus 1 over x plus 5. I'm going to leave some space because we need to multiply that by something. X plus 3 over x plus 5 over x plus 1. Okay, so this fraction is missing, this denominator is missing in x plus 1. So we're going to multiply by x plus 1 over x plus 1. Okay, so our first fraction, let's combine it. X plus 5 times x plus 1. Up top, we're going to have to FOIL. Okay, so more work. So x times x is x squared. Outer, x times 1 is 1x, so just x. Inner, negative 1 times x is negative x. These are going to cancel. Negative 1 times 1 is negative 1. Okay, minus the second part. X plus 5, x plus 1. So a lot of rewriting here. Okay, so from the first fraction, we said these will cancel. So let's combine them under one fraction. X plus 5, x plus 1. Up top is x squared minus 1. Now again, this minus is talking about minus this whole thing, this whole quantity. So this minus has to get distributed. So minus x minus 3, right? Okay. Combine like terms up top. X squared. Now the negative x doesn't have a like term. Negative 1 and negative 3 is negative 4. Right? Yep. And then x plus 5, x plus 1. So the top quadratic, let's see, we need two numbers that multiply to negative 4 and add to negative 1. So I don't think this is factorable because factors of 4, 2 and 2, but that's not going to add to negative 1, right? And then if we do 4 and negative 1, that doesn't add to negative 1. Or if we do negative 4 and 1, that doesn't add to negative 1. So actually, this is our final answer. And our restrictions is going to be, so that's going to be x cannot be negative 5 from here, and then x cannot be negative 1 from here. Okay? So that's all I have. It looks like we did 6 problems. So I think that should be enough practice for you guys. Hopefully you took notes on this. If you have any questions, please let me know. Feel free to rewind and pause and do whatever you need to do to slow down the lesson. I went a little fast because I didn't want this video to be too long, but again, what's cool about this is you can pause and rewind and go at your own pace. Okay, so let me know if you have any questions, and I'll see you guys later.